This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 1, Lesson 3, Sensible Heating and Cooling. When you heat or cool air without adding or pulling out moisture, the state moves straight across the psychrometric chart. The humidity ratio holds, the dew point holds, and only the dry bulb temperature changes. We'll fix that picture. Ground the standard air load equation, then work one clean cooling load. Concept 1. The horizontal move. A sensible process changes temperature but not moisture, so the humidity ratio stays put and the state slides straight across the chart. Heating goes right, cooling goes left, and the dew point never moves. Relative humidity does drift. Warm the same moisture and the humidity drops. The instant that line tilts, you have left sensible for latent. Concept 2. The load equation. For standard air, the sensible load is 1.10 times the airflow times the temperature change. That constant isn't arbitrary. It folds the density and specific heat of standard air. The printed derivation carries the 60 for per minute to per hour, the 0.075 density, and the moist air specific heat, and it collapses to 1.1. Use 1.1, not 1.08. Concept 3. Where the constant comes from. The Handbook prints one general relation. Heat equals the dry air mass flow times the enthalpy change. For a sensible process, constant humidity, that enthalpy change is just specific heat times temperature change. The familiar mass flow, specific heat, delta T. Feed in the standard air density and specific heat, and it becomes the 1.1 shortcut exactly. Same equation, constants baked in. Concept 4. Altitude. That 1.1 hides a sea level density, so up in the mountains, where the air is thinner, a given airflow carries less heat, and the constant drops below 1.1. The Handbook prints a corrected value at 5,000 feet. We defer the full altitude method to Lesson 9. For now, sea level and 1.1. But know the hook is there. Setup, the worked problem. A dry cooling coil takes 2,000 cubic feet per minute of standard air and drops it from 80 down to 60. The coil stays above the dew point, so nothing condenses. Purely sensible, a horizontal move at constant humidity ratio. The temperature change is 20. Solve. Plug the airflow and the 20-degree drop into the sensible equation, and the load is 44,000. Since no moisture changed, there is no latent part. So for this process, the sensible load is also the total load. That only happens when the humidity ratio holds. Traps. 4 ways this bites. 1. A sensible line is horizontal. If the moisture changes, it is latent, and the sensible equation alone is wrong. 2. 1.1, not 1.08. The shorthand runs low. 3. 1.1 is sea level. Thinner air at altitude carries less. 4. The airflow is standard cubic feet per minute. If it is actual airflow at odd conditions, drop back to mass flow times specific heat. Quick recall. A sensible process is a horizontal move at constant humidity ratio. Heating right, cooling left, dew point fixed. The load is 1.1 times airflow times temperature change, with 1.1, not 1.08, for sea level standard air. Underneath it is mass flow times specific heat. Golden rule. Confirm the humidity ratio holds, then it is one line. Next up, Lesson 4, Cooling and Dehumidification. Drop the coil below the dew point and moisture condenses. The humidity ratio falls and the line tilts down. The load splits into sensible and latent, tied together by the sensible heat ratio. Everything's at peprepengine.com. Cheat sheet, work solution, and a quiz attached here. If the course helps, subscribe.
The full study guide with every equation and common exam trap is free at peprepengine.com, link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.